Hi everyone! In today's video we'll talk about a Bloom filter. This is a very simple data structure that you can use when you need to check if something can exist in some dataset, usually a large dataset. I've prepared the code to show you what a Bloom filter can look like. This is a very simple implementation of the Bloom filter with three very simple hash algorithms. You might wonder why we need hash algorithms here. A Bloom filter is based on calculated hashes. We can see in our Bloom filter we have an array with some number of elements. When we add some elements to our Bloom filter, we calculate hashes for this element, and after this we change individual values in this array. Thanks to this, we can conclude that some element may have been added to our Bloom filter. We can't be sure that this element has been added because we have to remember that there is the possibility that more elements will have the same hashes. If we see at least one position with a false value in this array related to calculated hashes, we can be sure that this value wasn't added to our Bloom filter, and that's what a Bloom filter is all about. Let's tell you more about our code. Here we see the main method which we will use to test our Bloom filter. Here is a very simple implementation of our Bloom filter. We can define the size of our filter and the hash generators we want to use. For the sake of simplicity, our Bloom filter is dedicated only to numbers. We can't add any text value. We have the possibility to add some number by using the addNumber method, or check if some value is possibly present by using the isPossiblyPresent method. We have also the generateHashes method, which calculates hash values for some number, and getHashOccurrences to see the current state of our Bloom filter. At the very bottom of our code, we have the hash generator interface and three simple implementations of this interface which we will use with our Bloom filter. Let's run our main method to check how a Bloom filter works. After a while, we have our results here. I will copy these results to another tab. And we can see now, when we create our Bloom filter, all positions in our array are false, because false is the default value for the primitive Boolean type in Java programming language. In the next line of code, we added 2 to our Bloom filter, and we can see some changes in our array. We have true values in the 4th, 6th and 10th positions. After adding the number 9, we can see the true value for 0, 1st and 5th positions. After adding 17 and 1000, we can see more true values because these numbers generate other hashes. Now we are checking our test if some values are possibly present in our Bloom filter. We expect for the values we added that these values should possibly be present in our Bloom filter. And that's right, for all of these values, we see true as the result. For the numbers 19, 3, we see false values, so we can be sure that these values don't exist in our Bloom filter. On the other hand, for the numbers 100 and 4, we see true values, so we cannot be sure that these values don't exist in our Bloom filter, and we have to do some additional check, for example, in our database. This is an example of a false positive, and this can happen for some values while using a Bloom filter. We can minimize the risk of false positives by increasing the size of a Bloom filter. As you can see, we can use a Bloom filter, for example, when we want to minimize the number of calls to our database or to minimize the memory consumption of our application. In the description below, you can find a GitHub link to the code from this video. Thanks for watching and see you in the next episode.